Hello everyone. In this video, we are going to talk about the next natural product synthesis, that is Taxol. I have just recorded one video only for this synthesis because it is involving total 36 steps of the synthesis. Okay, so watch the video and simultaneously write down the synthesis part also. Of course, it won't be asked all together. All 36 steps won't be asked, but it will be divided into sub questions. And how it will be divided, that I will discuss in the next lecture. Okay. So first of all, Taxol. If you see, it is the Placlitaxel, which is sold under trade name that is Taxol. That is the anti-cancer drug. Chemotherapy drug. The Taxol is classified as a plant alkaloid extracted from the plants, that is alkaloid plants, a texane, and the antimicrotubule agent. So it's like against the growth of the, you can say, cells, we can just use this reagent. Taxol is used for the treatment of the breast, ovarian, lung, bladder, prostate, then melanoma, then esophagus, all as well as all type of solid tumor cancers. And it is also used in Kaposit sarcoma. Now, how to synthesize this Taxol? Let us talk about it. So the first step of this reaction is involving, if you can see this material now, it is your dyne and dinophile system. So you can see here, this is my dyne system and this is my dinophile system. Okay, so we are expecting there will be a Diels-Alder reaction. So this is 4+2 Diels-Alder addition. Along with that, we have also used this boric acid derivative, the boric acid, the phenyl derivative of the boric acid in presence of like in benzene as a solvent. So now what we are expecting, first of all, there will be cycloaddition reaction. So what I'm expecting over here, this particular compound, that is your this dyne system, it will be like this, right? And now over here, the concerted mechanism will take place, and this will form a bond with this alkene where we have this methyl group and this we have CO2 ET group, and then over here I have a CH2 OH group, and then I have OH over here also. So they will react with this boron derivative and they will form this cyclic adduct. You can see here these two OH, this OH and this OH. Now they have formed a bond with this boric acid derivative. So we are getting this cyclized compound. So there are two reactions over here in this case. One is the Diels-Alder reaction, 4+2 cycloaddition reaction also you can say. Followed by that, there is a like boric acid reaction to give this cyclic adduct. Okay, I'll just erase this. We'll go ahead for the next reaction. So now the next part is step number 2, that is involving the reaction with this glycol derivative, not glycol, diol derivatives. Now this diol derivatives, we are going to use it for the removal of this particular hydroxyl group, this boron derivative. तो यहाँ पे अगर उसको OH दे दिया तो वो remove हो जाएगा, and then I will get the OH over here and CH2OH here. Okay, so I will get this particular adduct formation. यहाँ पे अगर देखोगे तो इसको लिखते वक्त मैंने उसका cyclic chain जो है, that is I have written in this form. So if you see this particular part, ये जो ring part है, that I have drawn here. Okay, so here we can see there is double bond. You can see here, this is my double bond. It is attached to these two carbon. These are the bridgehead carbons. So it is attached to this bridgehead carbon. Okay, now over here, from here we can see यहाँ पे एक OH form होगा, तो यहाँ पे we can see the OH is formed here. Next is this part, this your cyclic chain, this 1, 2 and this 3 carbons, so that we have drawn here. Okay, and this is further attached to, यहाँ पे क्या होगा, ये निकल जाएगा तो ये बन जाएगा CH2OH. So I can see here the CH2OH group here, and the rest of the part, that means this chain, that is O and this, that is kind of your lactone chain is over here. We can see here the lactone chain. Now in the third step, there will be intramolecular reaction. Over here, this OH, what OH will do, it will break this bond and this will form a lactone ring over here and this will be set free. So this will become OH and this will form the lactone chain. Okay, so you can see here the lactone chain is formed over here and this OH is set free. Okay, now we are going for the step number 4. Step number 4, you are going to use certain reagent. First of all, the first reagent we are going to use is TBS. TBS is nothing but tertiary butyl dimethyl silyl triflate and L-lutidine and DMAP. L-lutidine and DMAP is kind of like a basic medium for this reaction, and TBS is a good protecting group. So what we are going to do, we are going to protect the OH. There are two OH in this group. You can see this one OH is here and one hydroxyl group is here. So we are going to protect them with the help of this TBS. Protection of OH hydroxyl group is done with the help of these reagents. So what is the role of all these reagents? First of all, your TBS is your protecting group. Lutidine and DMAP, they are kind of like a basic medium for the reaction, and dichloromethane is the solvent in this reaction. Okay, so when the protection will happen, you can see here I have written the TBS. So OTBS over here and OTBS. You can see, observe in the structure, whatever the change in the reaction is happening, that I have highlighted with the red font. Okay, so that you will understand this very well easily. So that it will be easy for you to understand that what exactly the role of the reagent in that starting material. Now the next is we are going to do the reduction of this ester group. This ester we have, this is CO2 ET. We are going to carry out the reduction of that, and for that purpose I'm going to use lithium aluminium hydride in ether. So when we'll use this, of course, this the ester will become CH2OH. The next part is deprotection. We are going to remove this protected group. Now reduction is done. So now the next part is to remove the protection of this OH group. Now why not this OH group? Because if you compare the two, this is less hindered, and therefore the deprotection of this will be very easy. For the deprotection purpose, we are using over here CSA. CSA is a camphor sulfonic acid. Okay, that CSA in dichloromethane and methanol combination we are going to use, and then we will have the deprotection of this OH. So we can see here there is a deprotection of this OH group. Further, we will allow this to react with TPS, Cl, and in imidazole and DMF. Imidazole and DMF for the basic medium. TPS is again a good protecting group. You can see the structure of the TPS. It's 2,4,6 triisopropyl benzene sulfonyl chloride. Okay, so it is a good protecting group for primary alcohols. So you can see in this molecule we have a primary alcohol group here. So we are going to carry out the protection of that. So I have written here OTPS. So we have protected this primary alcohol. Now the next task is we are going to use the condition like potassium hydride, that is a strong base. Then we are using benzyl bromide. Benzyl group will be our protecting group in presence of ether, and tributyl ammonium iodide. So that combination we are going to use for the protection of the group. And when this protection will occur, we will have this benzyl substitution. You can see here it's presented BZ. So we have protected this secondary alcohol group. So हमने क्या किया, पहले तो इस TBS को निकाल दिया. We have made it, we have to convert it into, or we have to protect it with some strong group now. So we have removed that TBS. First, while protecting, we have protected this primary alcohol, and then we have protected this secondary alcohol. So now all alcohol groups are protected, and now we will use this reducing agent, that is lithium aluminium hydride and ether combination, so as to break first of all this ester part, and then to carry out the reduction of this. Okay, so if you'll see here, this will become CH2OH, while this is kind of like aldehyde system, and that aldehyde will also become the CH2OH. So I will get 2 CH2OH at this position after reduction. Okay, so we are at ninth step of our synthesis. Okay, next step is we will allow it to react it with the again camphor sulfonic acid. We have already seen the structure, CH2Cl2. If you remember, what was the purpose of the CSA? Deprotection. If you remember, यहाँ पे हमने क्या किया था? हमने TBS को निकाला था by using this. So similarly, in this case also we are going to remove the TBS. So यहाँ पे और एक TBS है हमारे पास, so we are going to remove that. Okay, अगर ये TBS मैंने निकाल दिया तो what will happen? This will become OH, and this particular OH system, we are going to use the CH2Cl2, right? So this particular carbon we are going to use so as to protect it. So यहाँ पे एक protection भी step involved है. So in short, I'm going to get this. So if you see, ये OH बन जाएगा. Again, they will lose the this thing, water molecule, so as to give me this product. This is, you can say this is CH3, this is CH3. So it is kind of like the protection group. If you remember, in the previous case हमने ये भी use किया था, this one. यही है similar type of reagent हमने यहाँ पे भी use किया है so as to protect this to OH group. So this is my step number 10. So till 10 steps are completed, and we have protected this all hydroxy groups. Okay, now the next task is we are going to allow it to react with NMO. NMO is nothing but N-methyl formalin N oxide, which is a good solvent for the reaction. Then we are going to use TPAP, that is nothing but tetrapropyl ammonium peruthenate. Okay, so this is peruthenate is kind of like you can say this is also known as the Leigh Griffin's reagent. And finally CH2CN cyanide हमने use किया. So all these combinations are going to give us the oxidation. So if you remember the previous step, so previous step में ये जो अभी सारे groups को हमने protect कर दिया, ये OH को protect किया, ये OH को protect किया, और यहाँ पे भी protection है, तो यही एक OH primary alcohol बाकी है. So now what we're going to do, we're going to carry out the oxidation of that, and the primary alcohol will oxidize to give me formation of this aldehyde. Okay, this is my step number 11. Step number 12, I will allow it to react with N-butyl lithium. So that is used for the abstraction of the proton, followed by the Shapirot's reduction, जहाँ पे हमने ये protected group use किया है, and this Shapirot's reduction में ये group जो है ये it is kind of like a leaving group. So here this aldehyde group and this group, they are going to interact, and that's why I'm going to end up with this product. Okay, अब यहाँ पे क्या किया, if you see this particular part, this remaining part of the molecule is as it is. जो भी reaction हो रहा है ये aldehyde के ऊपर हो रहा है, तो aldehyde इसके साथ condense हो जाएगा. You can see here also this double bond is shifted here, so this will become NH2, and it is like the NH2 hydrazine will be the byproduct in the reaction. And over here I will get this reduction of Shapirot's reduction of this aldehyde group. Aldehyde group will become this alcohol, but there will be a carbon-carbon bond formation also in this case. Okay, so this is the Shapirot reduction. It's the step number 12. Now next I will allow it to react with the next, this is also a kind of like sharpless epoxidation that is going to take place. Now for this we have used, this is tertiary butyl hydroperoxide. sharpless epoxidation अगर याद है तो उसमें एक peroxide reagent लगता है, and vanadilyl acetyl acetoacetate that we are going to use for this. Vanadilyl acetyl acetoacetate, it is nothing but your chiral catalyst for this reaction, and peroxide we have used. So this is going to carry out the epoxidation. अब epoxidation कौन से group का होगा, तो यहाँ पे तुम्हें double bond दिख रहा है, तो यहाँ पे हम उसका ऑक्सीडेशन करेंगे, epoxidation करेंगे. So I'm going to get the epoxide formation via this step. So this is my step number 13. And finally, I'm going to do the reduction of this epoxide. For the reduction, I will use again the lithium aluminum hydroxide, and this epoxide will be reduced to corresponding hydroxyl group or alcohol. Okay. Now, till now, I hope you can watch the video again, and whatever the queries are there, just we can, I will clear it in the next lecture. Then step number 15, we are going to use phosgene. Everyone knows the phosgene is COCl2, and in presence of potassium hydride, which is a strong base, ether, and HMPA. HMPA is a hexamethyl phosphinamide, which is a polar aprotic solvent that we are going to use in the reaction. So during this reaction, you can see यहाँ पे एक OH group है अभी, और यहाँ पे एक OH group है. So ये जो है that will undergo the reaction with this phosgene, और यहाँ पे एक carbonyl substitution तुम्हें मिल जाएगा. Okay, by the removal of HCl. Next, step number 16 is its reaction with the TBAF. It's a tetra N-butyl ammonium fluoride. It's a salt and in presence of THF. So when I'm going to do this reaction, we can see here we are actually using this reagent for deprotection of this TPS, and I will get the unprotected OH back. You can also observe this TBS which we have added here, that is also removed from the molecule. You can see here this is TBS and this is becoming OH. So we have done the deprotection of that group by using this ammonium salt in step number 16. Next is the reaction mild oxidation we are going to use. You're going to use the TPAP. TPAP मैंने last slide में उसका structure discuss किया था with NMO, that same solvent. वहाँ पे भी हमने oxidation किया था. So now what is going to happen? You can see here we have a primary alcohol over here, and this is also primary alcohol. So all these, both this primary alcohol, they're going to become aldehyde. So this is mild oxidation. We can see here both of these are going to become aldehyde. Finally, its reaction with TiCl3 in DME. DME is nothing but the dimethoxyethane and zinc copper. So it is you can say McMurry coupling reaction will take place. This two aldehyde group, they're going to react, and you can see here they will form this kind of vicinal diol system. So these two aldehyde, they are going to react, and they're going to give you this McMurry coupling will give you the reaction, and that is going to give me the formation of this diol. This is on further reaction with the acetyl, you can say acetyl oxide, or you can say acetic anhydride, followed by DMAP. DMAP is the base. First slide पे discuss किया था. So these are the protecting groups. So we are going to protect one of the hydroxy group with the acetyl group. So acetylation, O acetylation हमने यहाँ पे कर दिया. Followed by that, again, I'm using the same reagent, TPAP, NMO, and CH3CN. If you remember, this is for mild oxidation we are using. And then mild oxidation of this hydroxyl group will give me the formation of ketone. So this has been converted into ketone. Then step number 21, where it is allowed to react with BH3, THF, H2O2. If you remember, in the presence of base, this is nothing but your hydroboration oxidation method. So hydroboration oxidation jab bhi hoga, so if you can see, this is my double bond here. Okay, and according to the anti-Markovnikov's rule, boron will go to the carbon which is less substituted, or which is, you can say, yes, it is less substituted carbon. So it will go to this carbon, and then followed by that hydroxylation will take place. So I will get the hydroxyl group, primary, the secondary alcohol over here. Then in the next step, we will allow it to react with HCl, MEOH, and water. This is a deprotecting group. So what will happen? You can see here these two OH, they are deprotected, and I'm going to get the free hydroxyl group. So this is a deprotection. So removal of that you can say protection group. Finally, the step number 24, where we are going to allow it to react with acetyl derivative again and DMAP and CH2Cl2. If you remember, तो हमने ये acetylation किया था ये condition से. तो ये जो primary है, secondary को protect करना difficult है, primary will be easy to protect. So यहाँ पे O acetylation होगा. And then we are going to do the again the deprotection using the hydrogen, palladium hydroxide, ethyl acetate, and the charcoal. Okay, so when I'm going to use this condition, we can see the benzyl group जो हमने यहाँ पे attach किया था, वो benzyl group को हमने अभी remove कर दिया. We have deprotected that group. So very strong condition, because if I told you before also, the benzyl was a strong protecting group which we have added, and now we have removed it with the help of this strong condition. Then step number 26, where we have used the TESCL. It is nothing but the chloro triethyl silane. Okay, again it's kind of like a protecting group, and हमने अब इसको protect किया with TES. You can see OH group को हमने benzyl से निकाल दिया, and now we are protecting it with the TES protecting group. Next step is its reaction with K2CO3 and methanol. So when we are protecting acetylation, previous step में यहाँ पे acetyl group था, तो उसको remove कर दिया with the help of this basic condition. So K2CO3 methanol, deprotection or the removal of acetyl group. Step number 28, again हमने use किया, that is TESCL and pyridine. So again this is the protection of that primary alcohol group. So you can see here we have added here TES, primary alcohol group को हमने protect कर दिया. And first, next one, we are going to use the triplet derivative with the help of the CH2Cl2 and IPR-NET. तो अभी triplet oxide क्या है? So trifluoromethane, sulfonic acid and hydride. And that is IPR-NET is nothing but NN dimethyl diisopropyl ethylamine. So this is triplet derivatives. Triplets are going to carry out the protection of this secondary alcohol. अब ये वाला जो है वो less shielded है, so it will be protected very easily. So we are going to protect it with the TF triplets. Why we do the protection with the triplets? Because in short we are converting the OH into good living group. हमें उसको निकाल देना है एंड में, तो उसको बेटर लिविंग ग्रुप बनाने के लिए वी आर कन्वर्टिंग द हाइड्रोक्सी ग्रुप इनटू triplet derivative. So now the next step is same, that is I'm going to use the CSA methanol and इस triplet को निकाल देंगे. Triplet को निकाल दोगे तो what will happen? You can see here ये वाला triplet hydroxide will be the byproduct and the ring is formed between them. So it is cyclic ring, oxide will be formed over here, sorry not here, ये जो TS है ये वाला नहीं है, ये OH as it is रहता है, ये वाला. This is removed and I'm going to get, wait, I'll just show you exactly again. There should not be any confusion. Okay, so what I said, what we have used CSA. If you remember camphor sulfonic acid, तो उसका reason क्या है? हम protecting group को निकाल दे हैं, right? ये protecting group जैसे निकल गया, तो यहाँ पे CH2OH बन जाएगा, and this will be the byproduct. Okay, and they will form a chain between each other. ये तुम्हारा secondary OH as it is है. This primary OH is forming the ether linkage over here. So this is our step number 30. Next, its reaction with the again AC2O, DMAP and CH2Cl2. Again, acetylation will take place. ये जो secondary alcohol है उसको protect कर दिया हमने OAC. If you remember, if you see the kind of reagents we have used, most of the time हमने similar reagents use किए. तो role अभी उनका याद रखना, it will be convenient for you. तो AC2O, DMAP, CH2Cl2. This is a condition for the acetylation. Always remember. Then its reaction with the phenyl lithium and THF, where these previous case, if you remember, यहाँ पे ये जो था हमने इसको protect किया था using this phosgene. अब phosgene को deprotect किया and with the help of this benzyl group हमने इसको OH बनाया और इसको protect, एक OH को हमने protect कर दिया with the benzyl group. The next one is the reaction with PCC NaOMe. PCC is the oxidizing agent, mild oxidizing agent. So it is going to carry out the oxidation of at this particular position. You can say this CH2 is becoming C double bond O. So for that, we are going to use this mild oxidizing agent PCC. Followed by that reduction. अब reduction होगा वही carbonyl group का, और carbonyl group यहाँ वाला जो है, you can see this was C double bond O, that is being reduced to OH. This is step number 34. Now almost towards the end of the reaction, last two steps. This is 35 step. We are going to allow it to react with this four membered nitrogen derivative. So now the ring will break at this position. This is NaNSi thrice twice. This is nothing but the sodium bis-trimethyl silyl amide. We are going to use it as a you can say base for this reaction. अब जब रिएक्शन ब्रेक होगा तो ये हाइड्रोक्सिल ग्रुप है ना, इसको प्रोटेक्ट किया जाएगा. सो वी कैन सी हियर प्रोडक्ट जब देखोगे, यू कैन सी यहाँ से ऑक्सीजन निकला है. देन you can see the next is carbonyl group attached. You can see the carbonyl group here. Next is attached to OTS. Next carbon is attached to pH, and finally the NH and benzyl. Okay, so we have attached this, protected that group with the help of this final molecule. And the last step, that is HF pyridine deprotection karenge. And with the help of deprotection, you can see this is TS, ये TS को हमने निकाल दिया, and we have got the last, that is hydroxyl group over there, and that is our molecule Taxol. Okay, there are 36 steps in the molecule. That's why I have just recorded this video for only one synthesis. Watch this video, write down all these structures in your notebook because it's going to take time. Okay, and next time I'll guide you what kind of questions can be asked. Of course, all 36 steps no one will ask you all together, so in steps wise it will be asked, and how it will be asked I will discuss it in the next lecture. Okay, so that's it for today. Thank you.